Hello and welcome to a new video on cryptography for everybody. In this video, I will show you how you can work with bits and bytes. We realize that working with binary data in Crypto2 is difficult. Therefore, we developed over the last weeks a new component which we named Byte Array Operations. That component allows to work, as its name suggests, with binary data. And in this video, I will show you some examples, what you can do with this component. And at the end, I want to encrypt a text using AES, and we will use the new component to put the initialization vector of AES in front of the ciphertext. Also, before we start, I would like to ask everyone who did not yet subscribe to this channel to subscribe to this channel. This really helps us to grow this channel and to make Crypto2 more popular. And now let's have a look at the Byte Array Operations component. I'm here now in the Start Center of Crypto2, and to work with the new Byte Array Operations component, we have to use the newest nightly build. This is 9.241.1. So you have to download the nightly build in that version, then you can also use the Byte Array Operations component. Let's first create a new workspace. And in that workspace, we need some data that we can work with. And to do so, or to create this data, we search for a text input component, and we add a text input component to the workspace. We have now different possibilities to create actual binary data here. First of all, we need a string decoder here. The string decoder can load in or can get a string and then decodes the string to different data types. We go to the settings here and we see the input format is text right now, but we set this to hexadecimal. Then the data that is written in the text input will be converted to a Crypto stream here and to a byte array. Let's create some test data like 01, 02, 03, FF and 00. And then when we have a text output here, we can see that this data here, when we start this workspace, is now converted to a byte array, and the text output automatically also displays the byte array as hex values. Now let's have a look at the new component, Byte Array Operations. As you can see, this component has a lot of inputs and two outputs. The first input is the first byte array, the second input the second byte array, and the third array, and the third input is the third byte array. Then you have two number inputs, operation parameter 1 and operation parameter 2. Now we need an additional binary input or binary data, a byte array here. So we just copy this here and we remove this here and we put our Byte Array Operations component here. Let's connect these two components now. And now let's have a look at the Byte Array Operations component. We have a huge set of different methods that you can use here, or operations. The first operation is a concatenate. And as the name suggests, we need first a text output. As the name suggests, this concatenates two byte arrays. This just means it takes the first byte array and the second byte array, and first outputs the first byte array followed by the second byte array in a third byte array. So when we press play here, we can see now we have 1, 2, 3, FF00, that's the first byte array, and then this here is the second byte array. Let's change this data here, for instance, to A0, B0, C0, and then some zeros and a 01. Now you can see here that every time we change this, of course, forwarded the data and concatenated the data to our new output. Let's name these components here. This is our first byte array 1. This is our second byte array 2. And this here is our result. Now let's have a look at some other of the operations. Another very useful operation, I think, is the subarray operation. For that, we can remove this connection here, but I don't remove these components since we will need them probably. And now we need two number inputs. a first number input. Let's call this number 1, and then we copy this, and we have a number 2. With the subarray operation, you get a subarray of our input array. Let's get a subarray from the position 1, so we count here with 0, 1, 2, 3, and 4. So we want to have the offset 1 here, position 1, and then we want to provide a length, and we want to have 2 bytes. When we now press play with the operation set to subarray, we should get 0203. And as you can see here, we have 0203 as our result. Very handy when you want to create binary protocols, for instance, and you need to extract data from, for instance, a header of a cryptographic protocol message. Now let's have a look at other methods. Okay, I think length and index of, these are both self-explanatory, but let's for fun test index of. So we could, for instance, connect the second array again. We switch this to index of, and we want to have the index of 03. We press play, and of course we need an output for that. So we need text output for displaying our number here, and this text output then is result number. When we now press play, we have index of 3 hex. I was looking at that text output. Yeah, of course. The byte with the value 03, hex 3, is at position 2. So we have 0, 1, 2, and as we can see here, the result is 2. Now let's have a look at some other useful operations. I think the reverse operation is also very useful. So you can see we reverse here the byte array. So we're starting here from 1, 2, 3, FF, and so on. We have 0, FF, 3 to 1. Then we have the replace. This is also very handy. And the replace operation replaces all occurrences of a given value or a set of values, a given byte array, by a third byte array. So we copy this once more. I hope you can see this or that I'm not in the way. So this is byte array 3. And we want to have AB. So when we change, we set this to replace, we want to replace in this array all occurrences of 00 by AB CD. So let's press play. And of course I should connect the third byte array here. And let's tidy these here a little up. Let's press play. So we have the first 00 at the first position at offset 1 here. So we see here A, B, C, D. Then in the end we have also 2 times 00. So we have A, B, C, D, A, B, C, D in the end. I think this is also very handy if you want to replace some data in a byte array. Now we have a set of Boolean functions here, the AND, OR, exclusive OR, NOT, left shift, right shift, and left circular shift and right circular shift. Let's first have a look at AND. Let's imagine you need only the third value here, but you want to have the complete array. So you don't want to remove this or use subarray. You just want to have this second position. So we could use a bit mask and we enter 00, then FF 00, 00, 00, 00, 00. And now when we set this here to, or we already set this to end, when we press play, the first array will be ANDed. So binary or a Boolean ANDed with the second array, and you get here the third array. And 01 and 00 is 00, 00, 00 ANDed is 0. And then here in our second position, or in offset 2, we have the FF in the second array. So 02 FF is 02. I think this is also really useful. And of course, when you change this array here at different positions, you see that only the FF position here, since we use the AND, remains here. Now let's switch to another useful operation. So we have OR. Let's switch. Oh, and by the way, we have the very nice feature here. You can change this to binary and this to binary. And then we can work with binary data. So 1, 2, 3, 4, 5, 6, 7, 8. 2, 3. Same here. 1, 2, 3. And since I also want to see the binary data here, instead of using the direct connection here, I will use the string encoder and then set the string encoder also to binary. Because now we can see binary data. So we give in 0, 0, 0, and we have the, I think, OR operation, yes. And again, 3 zeros or 3 bytes completely set to 0, but with in a binary representation. And the result are also 3 bytes all set to 0. Now we can set here some ones, for instance, at this position, and it automatically is set here. And of course, when we set here positions also to 1, single bits, then since we use the OR operation, we see that we get the OR of these 2 byte arrays here. Now let's have a look at the XOR. And the exclusive OR or XOR, we also use several times on this channel for modern ciphers. For instance, when we worked with S boxes, we XORed the result of the X boxes and so on and so forth. And let's have a look at the XOR. So XOR or exclusive OR uses or takes both arrays, and then all positions where you have at the same offset a 1. So for fun, let's change the last position to 1. Then we have here 1. Since we have 1 XOR 0, this is 1. Also, when we exchange this, so we have 0 XOR 1, we get a 1 at the end. But when we change both to 1, since we have XOR, 1 XOR 1 is 0. So this is also very useful. And now for some operations, you may need the NOT. So the NOT just changes each 0 to 1 and each 1 to 0. As you can see here from the first array, we have 4 ones, and you have here 4 zeros, we have here 4 ones, then we have here a 1, and we have a 0. So it inverts all the bits, also very handy. And then one of my, or two of my favorite operations are the left shifts. For that, I remove this. We don't need, oh, that was too much. That was all right. I need a number input here for the shift operations. The shift operations shift all the bits to the left or to the right, depending on which shift operation you have. For that, to show that, I just change everything to 0, and we only have a 1 at the first position. We set the byte array to left shift, and let's shift everything 1 bit to the left. Then you can see this one here goes 1 step to the left. And when you change the number, the bit also changes, or the shift value changes. I think this is really nice and helpful. Now, you can also do this with the right shift in the other direction, but there's also a circular shift. So let's set our one here. And we remove this one here. And we have a shift of 1. So you can see that the 1 goes 1 to the left, then 2 to the left, 3 to the left. Now comes the interesting part. We have shifted the 1, 3 to the left, so it's in the end. But when we shifted 1 more, it would be shifted out of the array. But since we use a circular shift, you see that the 1 that is shifted out goes back into our array. And when we even shift further, you can see that the 1 even goes further. So a circular shift wraps around when you shift. Very handy also for cryptographic algorithms that use circular shifts. And now we know how this byte array component or byte array operations component works. Now let's create a cipher setup where we use AES and we want to concatenate the initialization vector at the beginning, then turn the binary data into an other data form of data, for instance, into base 64, and then decipher this also. So I remove everything here. We need a key. Let's remove everything. So we have here, first of all, we need a plain text. And we want to have hello world. Then we need a key. And we use a password because we can use, for instance, pkcs5. Or no, let's use pbkdf. This is password-based key derivation function. And we use pbkdf1 SHA-256 and iteration I set to 10,000. That's the amount of hashing, a hash algorithm performed on our password. And we need an AES for encryption. And as I said, we need an initialization vector, and for that I want to use a random number. The random number should generate cryptographic random number, and we need 16 bytes for the AES. This here will be our initialization vector. This here will be our key. And we have to convert. Oh, I think we can directly even connect the string to. No, we use a converter for that. Otherwise, we would lose the UTF-8 characters. So we have, no, that was wrong. We need a decoder here because we want to work with UTF-8. And this also converts this to a nice crypto stream. Now let's have a look at the output. And the output here will be hexadecimal. So let's start the workspace. And the AES has a problem. We have a too long key. So reduce this to 16 byte. Or we just change the AES to AES 256 bit. Then we can leave the 32 byte here. And you can see every time we restart that workspace. Oh no, you can't see that. We have to change the chaining mode to cipher block chaining. Now every time we restart the workspace, you can see that our ciphertext here changes. Now we have a problem, and for that we use, or to solve that, we use the Byte Array Operations component. Our problem is that we lose our initialization vector right now. It goes into the AES, then we get our ciphertext here, and this ciphertext then cannot be decrypted without having the initialization vector. And we will store the initialization vector in front of our ciphertext. We do this by using the array or byte array operations here. We have to convert here, so we need a converter for that. And the converter allows us to change a crypto stream, or to convert a crypto stream into a byte array here. So we have byte array here. We put this in the byte array operations, concatenate, and we put also our initialization vector, but that is the wrong order. I want to have it at the beginning. So we have to first put the initialization vector here and then our ciphertext. Now we have another text output here. So here we have our ciphertext, and here we have our IV plus ciphertext. This here is our This is our IV, our initialization vector. Yeah, let's test it. And now you can see we have our ciphertext 5F, 9A, and so on. This is here. And we have our initialization vector 16-bit here. The final thing we have to do is we have to add a padding mode, and I use PKCS7 as a padding mode. And every time now we restart this workspace here, we get a different ciphertext and IV, of course. Now we, of course, want to decrypt this. For that, I copy everything. And let's change our password to password here. For that, to decrypt this, I create a new workspace by copying everything and creating a new workspace. Now we change the AES here, of course, to decryption. And of course, we don't need the IV generation, since the IV is part of our ciphertext or of our data. Now we have to remove this connection here, because of course we have to copy our ciphertext here to the new workspace. This is now ciphertext. This here is not text, this is base 64, and the decipherment will be, of course, this is decrypt, and we have to add a converter here, encoder, string encoder, because it will encode our string here to UTF-8. So text UTF-8, this is right. Now we have to extract. First of all, we can take this here, put this into the first byte array operations component, and we need two number inputs. We need one number input. This is for the offset, and our initialization vector starts at 0. And we need a second number input. This is the length. And we will probably in the future also add settings to the component so that you don't need number inputs for that. But this is future work. Right now you have to do this way. So we have 0 offset and we need 16 bytes. So this is for our IV. And the IV then goes into the AES. And now we can copy this for our ciphertext. And this is, of course, here then IV plus ciphertext. And the ciphertext then starts at offset 16. And it will use or will have the length of our IV plus ciphertext minus the length of the IV. And so we have to compute this length here. So we have to remove this. Then we can use also a byte array operation component here. This is the length of. And this will give us the length of this byte array here, or this encoded byte array. Then we need a number operations component to subtract the length of our IV. This is here. And we need to subtract another number. And we need to subtract the 16 here. So now we have here len of ciphertext. And we can put this into the ciphertext sub array or byte array operations component. We have to take our IV plus ciphertext here. And from that we get now our ciphertext only. We have to convert this here again to a crypt tool stream. So we put this here. This will be a crypt tool stream, and the crypt tool stream goes into the AES. So let's tidy this a little up. Okay, it's a little chaotic here. So we have here our two numbers. The offset 0 is the offset of the initialization vector. The 16 is the length. So we say offset IV, and this is len IV for length IV. Then here we compute, why did I put 16 here when we have 16 already here? So we can use this 16 here. Because the 16, which is the len of the IV, is also the offset of our actual ciphertext. So we compute here the length of the ciphertext, and with the subtraction here, and then with the second byte array operations component, we extract our ciphertext. Now let's press play, and let's see if everything works. Okay, so what does not work? Now it works. Okay, so let's explain what I just did. Okay, the both components here, the both byte array components operation components were set to the wrong operations. So I set the length of to length of, I set the ciphertext extraction here to subarray. Also, the string decoder was not set correctly, it was not set to hexadecimal. And this string, okay, this is set to UTF-8. Now I said we want to create workspaces that allow us to encrypt to base 64. So I have to adapt our encryption workspace here. We need also a string encoder here. And we use this string encoder and we change this to base 64. I now press play. I get a nice base 64 string. I can paste this in the second workspace, and now I change this here to base 64. And I can also, why doesn't this work? Okay, because I'm stupid. I have to do this for the IV and ciphertext, of course. Now we have IV plus ciphertext, and I think I'll just remove this here so that we have here our ciphertext and IV. Now, okay, now it's even longer. I can copy this, paste this here, stop, restart, so we see no errors at all. And of course, when we change our password, it should not decipher or decrypt. Yes. So we created a nice small protocol where you encrypt a text, UTF-8 text, using a password. The password is then changed to a cryptographic key by PBKDF, I think 1. Yeah. Then it's encrypted here by AES. The AES uses cipher block chaining mode with the IV that's randomly generated. And in the end, we get a base 64 encoded cipher IV plus ciphertext. And in our decryption workspace, we take this IV plus ciphertext. We use our new Byte Array Operations components to split the base 64 or the binary string or byte array that we have then decoded using the string decoder here. We split this into the IV and in our ciphertext again, and then we use the AES again to decrypt this, and finally to encode this again using a string encoder into UTF-8 text. And I think the Byte Array Operations component is really helpful for doing this. Previously, you needed to convert to hex strings. Then the offset handling was very difficult because you didn't work with bytes, but with 2 hex values and a space. And I think this is a really nice addition to create such nice and simple cryptographic protocols. And I think this is the end of the video. I hope you liked it. If yes, please give a thumbs up. Also, as I already have said in the beginning of the video, if you did not yet subscribe to this channel, please do so. This really helps us to grow the channel and to make Crypto 2 more popular. So, thank you very much for watching and see you in the next video.